Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of comparing numeric data. This is standard 7.12a in the great state of Texas, and we are using item number 17 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have a box plot here, and actually it's a double box plot because it shows data from two different sales teams and the amount of sales that they have. So we've got four statements we need to look at here. So we'll look at some of the terms related to box plots: range, interquartile range. So let's look. The range for sales team X is $10 more than the range for sales team Y. Well, let's see what the range is. That's the difference between the greatest and smallest. Greatest and least, we could say. All right, so the range for team X. Well, this one is sitting at 125. And then that's the greatest. The least is going to be 70. Right, so 125 minus 70 is going to be 55. So the range for sales teams X, 55, is $10 more than the range for sales teams Y, which is 130 to 65 to 65. And we can go ahead and calculate that, but we really don't need to because visually you can see it's not going to work, right? That's 65. If they had flipped these two, this would be a good statement, right? If you said the range for sales teams Y is 10 more than sales teams X, that would have been fine. Or if you want to keep the X and Y, you could have said less. And also visually, you can see there's a $5 gap there. There's a $5 gap there. So there's a $10 gap overall, but it's the sales team's Y that is more, not the sales team's X. All right, the interquartile range. So these are your quartiles right here, and inside this box, that's the interquartile range. For sales teams, X is half the interquartile range for sales teams Y. All right, sales team X, we've got a 75 and we've got a 90. Okay, so the interquartile range for sales team X is 90 minus 75. All right, that's 15. Is half of what it is for, that's a 75. And we've got 105. All right, so 105 and 75, 30. So 15 is half of 30. Yeah, I mean that looks pretty good. I'm going to question mark this just to make sure everything else is wrong. Visually, you can see they start at the same spot, and even though this dot is in the middle, doesn't mean it's exactly in the middle, but visually it does kind of look like that also matches. That's about halfway. Okay, so we're looking pretty good on B. The mean, okay, the mean is the average. Okay, so what that means is you take all the numbers in the data set. That's the sum of all numbers, and you divide it by the number of, items or the number of numbers in there. That's how you get your average. We don't have a data set here. We have a representation of the results, but this doesn't tell us what the mean is. Now, if you wanted to say median, that's the middle number, right? When put in order, that's what this number is, this dot right here. And sales teams X is $5 less than sales teams Y if you're looking at the median. But this is a very tricky one because it's using the wrong word here. We don't know what the mean is because we don't know what the data set is. If that were median, it would work. And then finally, the interquartile range for sales team X is twice. We already calculated that. It's not twice. So this is the opposite of this. One says half, one says twice, right? 2 times and 1/2. And this one is the one that's incorrect. Because sales team's X is clearly the smaller one. So it's not going to be twice the interquartile range of sales team's Y. So we have our correct answer, and it is B.